Okay, this video will demonstrate some of the word problems in our textbook regarding parabolic motion, objects traveling in a parabolic shape or on a parabolic path. We're given two formulas to work with. One formula for units of measure in meters, the other formula for units of measure in feet. The parts of the formula: the T stands for time, the R stands for the rate of the object, the rate at which the object is moving or traveling through the air. The H stands for the height of the object at any given moment in time. And I've taken this and I've turned it into function notation to help you understand function notation a little bit better. We're just simply taking these formulas and calculating the height of the object at a given moment in time, at a particular moment in time. You can see that the coefficient on the squared term in both formulas, the coefficient is negative, indicating that we'll be studying downward motion. So just common sense, the object leaves the ground, travels in its parabolic path, and then comes back to the ground. So the word problems that we'll be solving will be figuring out the height of the object at a given moment in time. And we will associate time with the x variable, and then the height of the object will be associated with the y variable in an ordered pair. So we will have an ordered pair instead of with an x and a y, to give an analogy. Instead of looking at an ordered pair with an x and a y, you can think of our ordered pair as t, h of t, or the height of the object. So along its parabolic path at certain times, the object is at a certain height at a given moment in time. And as it travels through the air, another time, another height, another time, and another height, all along its parabolic shape. So we'll be finding these particular heights at a given moment in time. And we need to go back to the vertex. Points occur in parabolas in pairs. So you can see you've got pairs parallel opposite each other. The vertex sitting at the top is the only point on the parabola that does not have a partner or a pair, or another pairing on the opposite side of the axis of symmetry. So the vertex in a downward parabola represents the maximum height. So the vertex is your maximum height. So we'll be studying word problems that will ask, when did the object attain the maximum height? Well, that's your t variable. And then the second part of the problem will ask to measure that actual height. Well, how high was it at that particular time? So this is what we're studying. And let's do number 17 together. A ball is thrown upward with an initial speed of 24.5 meters per second. So the first thing to do when you read the problem is figure out which formula you're using. This is a meters problem telling me that I need to use this particular formula, because this is the formula for measurement in meters. And I'll be replacing parts of the formula. The rate is always given, so this object is traveling at a rate of 24.5 meters per second. And then part A says, when is the object 19.6 meters high? Well, in this particular problem, this is my h. So let me replace the pieces in the formula. H becomes 19.6, R becomes 24.5, and 4.9 is something to do with gravity, so that stays standard in this meter measurement equation. So what we have to do is factor for t. T would be our x variable. That's what we're solving for, is t. But before we can do that, we have to put the quadratic in standard form. And now I'm setting this equal to 0. You've now learned the quadratic formula, so you're welcome to use the quadratic formula with the a, b, and c. Or you can do this with factoring, and these are nice textbook problems set up to work out well. If you remove 4.9 from each term, you end up with something really simple to work with. I end up with this quadratic, which I can easily factor as t minus 4 times t minus 1, giving me two t values. T is 4 and t is 1. And what that means, t is 1 second, time of 1 second, or time of 4 seconds. And so the object is at a height of 19.6 meters at the 1 second mark as well as at the 4 second mark. And let me erase the board and let's analyze this information and move on to the next part of the question. So here's the object traveling through the air, and we just discovered two routes. T is 1 and T is 4. So that means after takeoff, and we'll consider this initial starting here, after takeoff, at the 1 second mark, this object was 19.6 meters in the air. And it kept traveling, and then again at the 4 second mark, it was also back to a height of 19.6 meters. So part B asks, was this the maximum height? Was 19.6 the maximum height achieved or attained by this object? And then the second part, why or why not? Was it the maximum height, yes or no? And then explain why. Well, clearly it was not the maximum height because it went through the height of 19.6 two times. It went through 1 second after takeoff, traveled beyond 19.6, and then on its way back down, it came through 19.6 one more time. The maximum height, up here at the top, the maximum height, will be associated with the vertex. So parts C and D of the question ask us to figure out when it reached its maximum height, and then to determine what that actual height was. So remember the x-coordinate for the vertex of the parabola, we use this little formula, negative b over 2a. And to find the x-coordinate, I can use the factored form of my equation, or I can simply go back to the original. I think I'll go back to the original equation on this. I think I'm going to go back and do this. Meaning this is A and this is B. So this would be associated with T, or time. So to calculate the time it took to reach this maximum height, here's my formula. The negative sign is built in. Negative b, 24.5, over 2a, for negative 4.9. And going through the algebra, use your calculators, please. This turns out to be positive 5 over 2, or 2.5. So to put this in perspective with real-world time, this is about 2.5 seconds after takeoff. About 2.5 seconds after takeoff, it reaches its maximum height. And then, of course, part D says, well, what was the actual height? And the reason I went back to the original equation, we had used 19.6, a height of 19.6. Well, now we're trying to solve for a different height. So that's why I went back to the original equation and I replaced 19.6 with the variable h. And now I have a value for the variable t, which I could substitute in, allowing me to easily solve for h. So 24.5, substituting in 5/2, or you can use the decimal 2.5. Making the proper substitutions, using your calculator, please, you get a height of 30.625, and this is a problem in meters. So 2.5 seconds after takeoff, this ball reached a maximum height of 30.625 meters. So that's summing up the problem.